and then I'll share the screen. So this will be basically a review from 8.5. Whoops. All right, from 8.5 review. So I wanted to do one of the questions towards the end because some of y'all might not have understood my notes about how I was canceling out some of these asymptotes. So for this problem, they want me to list the domain, x and y intercepts, find the vertical asymptotes, find the horizontal asymptotes, and then looks like it wants us to graph. So they're giving us f of x equals x squared plus 2x minus 15 over x squared plus 7x plus 10. So really, the easiest thing to do to these is to, when you got trinomials like this, you want to try to factor them to see what kind of factors are making up this top and bottom, because that makes a big difference when I'm finding domains and my vertical asymptotes. So what I'm going to do is factor the top and factor the bottom. So on top, you got an x squared. So that's going to put an x in the front of both parentheses. The last number is negative. Anytime that last number is negative, one of these factors is positive. One of these factors is negative. All right, when it's negative, I want to find factors of 15 that subtract to get 2. So 15 is 1 and 15, 3 and 5. 3 and 5 subtract to get 2. Now, since this 2 is positive, the larger of those two numbers, which is 5, would be positive, and then the 3 would be negative. So now 3 and negative 3 equal 2. 5 times negative 3, multiply to get a negative 15. Okay, so now I would factor the bottom. So that's going to be an x squared, so you got an x and an x. This 10 is positive. Anytime the last number is positive, both of these factors over here will have the same sign as that middle number. So the middle number is positive, so both of these will be positive. And then I want factors of 10 that add to get 7. So that would be what? 1 and 10 get 11, 2 and 5 add to get 7. So I'm going to put 2 and 5 in here. Okay, so it makes a difference on these, on the asymptote part of this. Now for the domain, we know what to do for the domain. So the first thing I'll find is my domain. And they want these in interval notation, okay? So to find the domain, I take the bottom, x squared plus 7x plus 10, and set it equal to 0. Now, I've already factored out the bottom over here, so we know that's a x plus 2 times a x plus 5 equal to 0. And now to get the answers or the zeros, we set both of them equal to 0. All right, so first equation, I'm going to subtract 2. So x cannot equal a negative 2. Now remember, since I'm doing domains, I usually put not equals here, so I'll do that on all these. And then the other one would be x plus 5 cannot equal 0. So let me minus 5 on that one, and I get x cannot equal a negative 5. Now remember, in interval notation, the domain has to start on the left side, which is negative infinity. And then you go through the x values until you come to the first number here. Well, the first number you're going to hit going left to right is negative 5. So we're going to union around negative 5, because that's how we kick these numbers out of our domain, is by unioning around it. So I can go from negative infinity up to negative 5, but since these are curvy, I cannot equal negative 5. Then I start on the right side of negative 5, and I go to the x's until I hit negative 2. Cannot equal negative 2, so we use curvy parentheses, union around that negative 2. So on the right side from negative 2, since I don't have any more numbers to exclude from my domain, it'll go from negative 2 to a positive infinity. Okay? So domains, you never use brackets. They're always curves because they cannot equal those two numbers. All right, let's see what was next. It wanted me to find x and y intercepts. So to find the x-intercept, you would take that top and set it equal to 0. But one thing you got to watch for on the x-intercept, you see this factor of x plus 5 up here? It's going to cancel with this factor of x plus 5, because an x-intercept cannot occur where the function is undefined at, okay? So what would happen on the x-intercepts, this x plus 5 would cancel with that x plus 5. So all I would have to do is take my x minus 3 factor and set that one equal to 0. So remember, we'll write this note on the side. The x plus 5 factor canceled out with the same factor I'm going to pull that over just a little bit, with the same factor on the bottom. Okay, so an x-intercept can cancel out a vertical asymptote, which is what that bottom is going to give me eventually. All right, so now x-intercept, x minus 3 equals 0. So now we would add 3, and I get x equals a positive 3. Now remember, when you do x-intercepts, you got to put them in MATLAB like an ordered pair. So the x value was 3. And then the y value, to be an x-intercept, the y value always has to be 0. And that's what they was doing with that one little lesson where we were finding x-intercepts, and then we were finding the zeros, and we were saying basically they were the same numbers, okay? The main thing on this part right here on the x-intercept is, remember, if a factor on top matches the factor on bottom, it cancels out that x-intercept. All right, so now to find the y-intercept, because they wanted that next, to find the y-intercept, you find f of 0. So f of 0 means take my function, which is my f of x right here. That means take that function and put zeros in for all 4 of these x's. So f of 0 will be 0 squared plus 2 times 0 minus 15. That'll be over the bottom, which is a 0 squared plus 7 times 0 plus 10. You know, guess what? 0 squared is 0. 2 times 0 is 0. So the only thing I got on top is a negative 15. The bottom I got 0 squared is 0. 7 times 0 is 0. Plus 10 would give me a positive 10. Okay. All right, now I can reduce the negative 15 over 10 to a negative 3 halves. So remember, to be a y-intercept, we plug the 0 in for the x, which means the x value will be 0. The y value would be a negative 3 halves. So I found my domain. I found my x-intercepts. I found my y-intercepts. Next, they wanted me to find a vertical asymptote. I don't know if I say that right. Asymptote. Close enough. So to find the vertical asymptotes, you would take the bottom factors and set them equal to 0. But remember, you cannot have a vertical asymptote where you have a factor on top that cancels it out. So it canceled it out as an x-intercept. It's going to cancel that factor out as a vertical asymptote. And what it'll do, instead of having an asymptote there, it'll sort of go along and just sort of make a hole in the graph. But on our calculators, you can't see the hole because the way the pixels are on them. But yeah, technically, instead of a vertical asymptote, it would actually make a hole at that point. So on the bottom, since my x plus 5 factor canceled out, the only factor I got to worry about is the x plus 2. Set that one equal to 0. And then right here, the x plus 5 factor canceled with the x-intercept on top. So I just want y'all to remember, these two canceled each other out. It canceled it out as the x-intercept, and it canceled it out as the vertical asymptote. So I've only got one vertical asymptote, so let's solve that. And my vertical asymptote would be the imaginary line x equals negative 2. All right, so then it wanted us to graph it. So I'm going to sort of try to, I think I got graphing paper. So I'm going to let y'all write that info real quick, and then we're going to graph this on graphing paper. And then you would know which sort of picture to pick. Now, you can graph this on the calculator. If you graph this on the calculator, you need to put parentheses around the numerator and then put parentheses around the denominator. If you don't do that on the calculator, it will not give you the right graph, okay? All right, so let me graph this now. All right, and I had a ruler so I can make these lines better now.
Oh, I have a question.
Yeah.
So when we graph them and plot the points and everything, how do you know where the lines fall? Because sometimes when you have it in the when you have two lines that the arrows cannot pass through.
So watch this one, and maybe this will give you an idea of what I'm looking at to show you which way they're going to go up or down with.
Okay.
And that'll come because of all of our other zeros and stuff. So the first thing I would do when I graph these is I would graph that vertical asymptote. Oh, and I got to find a horizontal asymptote, so I'll find that in a second. I forgot about that. But my only vertical asymptote we had on here was x equals negative 2. So over here, I'm going to say this is negative 1, this is negative 2 right here. At negative 2, I would have an imaginary dotted line coming up through there. Now, since that is a vertical asymptote, our graph cannot cross this line and touch it. Okay, so what happens is one side will go either up or it'll come down, and they head towards infinity. And y'all, they can get really close to that line, but since it's undefined, it will not cross it. So one end typically comes down and one end will typically go up. Although some graphs, they both might go up or both might go down. So we got our vertical asymptote here. That was our vertical asymptote. X equal to A, -2. Okay. So then the domain don't really matter because we just know it's going to be undefined here. And then at what was the other one? -5. Remember over here at -5. So here's -3, -4. Here's -5. Over here at -5, remember, I had a x-intercept cancel with my vertical asymptote. So over here at this -5, technically, there would be like a hole there. Because the graph cannot cross where that hole is because it's undefined right there too, okay? So you would almost have a little hole there. So we found an x-intercept. We said the x-intercept was 3, 0. So over here at +3, we got 1, 2, 3. So here's +3. We know it's crossing that line right there. Okay. Now, what did we find next? We found over here, we found a y-intercept. We said the y-intercept was 0, -3/2. So if you was to figure out -3/2 on a calculator, that would give you about a -1.5. So at 0, -1.5, I know it's going to cross this y-axis. So here's 0. That'd be what, -1, -2. So about halfway will be my y-intercept at a -3/2. Now, the one I didn't find, let me do that real quick. We can do it over here. The horizontal asymptote looks at the degrees of the top and the degree of the bottom. If the top was bigger, your horizontal would be y = 0. If the top was bigger than the bottom degree, then it would have no horizontal asymptote. If the bottom degree was higher than the top degree, then it would be y = 0. When the degrees match, when you got a 2 on top and a 2 on bottom, when the degrees match, your horizontal asymptote is the ratio of A over B. Well, the number in front of the x squared would be a 1. The number in front of the bottom x squared would be a 1. So you would have 1 over 1, which is 1. So my horizontal asymptote would be y = 1. So what that means on my graph is out here somewhere heading that direction and out here somewhere heading this direction, my graph is trying to get to that value of 1 on that graph. It never reaches it, but it'll try to get there. So, Christine, let's think about this. I'm going to play with this side first. Remember, that's the only x-intercept I got. So that means this point cannot come back up. It cannot go up and cross that line again. So since I know it's touching the line here, it's going to come down like this. So watch me, it's going to come down. And then since it cannot cross that line, I'm just going to keep on going down. Now, the reason we knew this didn't go up, because it could not cross that x-axis again. It had to stay under it. So since this one came up, and I know I got me a horizontal asymptote out here trying to get it to 1, on the right side, it's just going to keep going, and it's going to try to get to that 1 right there. But it really never can reach it. It just gets closer and closer as you head towards positive infinity. Okay? So what's going to happen on this side, I know I was undefined here, right? So it was a hoe. So since this side's coming down, this side is going to want to come up that little y-axis. But remember, it never can cross over, so it's just going to keep going up and up and up. And then over here, this one's just going to sort of go down and down. So I just look at these few points right in here. Where's my vertical asymptote? I know I can't cross it. Where's my y-intercept? Because that tells me everything about what's happening to the line. And then x-intercepts, remember, x-intercepts is where it's crossing this. And it only crossed it once and was defined. On this side, it's going to make a hoe. And I'm not sure on the MATLAB if you can actually see the hoes or not. They're sort of tricky, but here would be the pictures of their graphs. Seeing if you notice. Ooh, that was hard to tell. So mine crossed over at 3, so I would need this one that crossed over at 3, okay? And then it's sort of trying to get to that asymptote of 1 right there as it goes out. So calculator, like I said, would knock those out really quick. And then you can just look at which picture. They're going to want to make y'all actually graph those because they're sort of tricky as you seen when we was doing it. But yeah, if you ever wanted to, that's the things you look at when you're graphing them, is those x and y intercepts and then them asymptotes.
I have one more question.
Yes.
So what does it mean when it asks you what is the equation of the, is it oblique?
Oh, you're looking at the oblique asymptote?
Yes, yes.
If you get to that question, they should have taken all the problems out of those that had that actual work on it. So all you would do on that one is just put there is no oblique asymptote.
Oh.
Yeah, I forgot to say that on my video, I think, but yeah, it'll have a place for it, but just put there is no oblique asymptote because our math chairperson was supposed to take any questions that had the oblique on it. We don't really cover those ones, so.
Okay, thank you.
But what they would mean by oblique is it makes a line that's sort of like angled, and it'll come to one side of it and sort of be symmetric on both sides. But now we don't mess with those, so. Now, y'all, 8.6 is polynomial inequalities. And on these, I'm going to be writing my answers in set builder notation. I mean, interval notation when I'm done. So remember, when you're graphing inequalities and doing set builder notation, I mean, I'm going to be right now, interval notation. So for interval notation, if it has greater than or less than, you're going to use parentheses. If there's an equal sign under those, we're going to use brackets. So what I'm going to do first is show you the steps I would do to solve a polynomial inequality. All right, so the first thing I do is I set the polynomial equal to 0 and solve. All right, so set that polynomial equal to 0. You're going to solve it. Then I'm going to set up a number line using the solutions. So I'll have me a number line going across, and my two answers, I'll set up a solutions, or you might only get one solution because it might be a repeating solution, and it might be that pattern. But you'll get either two solutions or one on these, okay? So what I do, we're going to take our numbers and put on the number line. Then we're going to test the region where 0 is located on the number line. And I'm testing 0 because 0 is the easiest number to stick back into a polynomial and work, okay? Because of those exponents. You can check any number you want to, but 0 is the easiest, so always check the region where 0 is located. So if you had two solutions, then the outcome will be, okay, so watch what I'm doing. I'm going to draw my number line in A and B. So y'all, if 0 was in the middle region and 0 was true, then I would shade in between my two numbers. And I would not shade on the outsides, okay? So it's in between them if it's true. And you cannot have two regions in a row that are the same. So not shaded, shaded, not shaded. Or, watch this. If my 0's in the middle and it was false, well, if it's false in the middle, then that means the two outside edges would be shaded. Okay? So if this is shaded, this will not be shaded. This will be shaded. If this is not shaded, the middle will be shaded, and the other side will not be shaded. Okay? Now, if I only had one answer, say it was like this style here, then I would go negative infinity, union around that number, and then go to positive infinity. You only got to worry about the number lines if you got really more than one answer, okay? All right, then my last thing, right interval notation. For the solution. But here's the kicker on this one. If the polynomial does not factor, so if the polynomial does not factor, then it is a no solution. And in here for no solutions, they're going to introduce you to the 0 with a line through it. I think that's actually on the MATLAB as one of your options when you go down there and you find the infinity and stuff. I believe they have the, we call that the empty set or no solution. So we're going to work a few of these, and this will be it for test 3 material, okay? And then I will review tomorrow for test 3. Alrighty, so let's go to some of these examples. All right, so solve the following inequality. And that'll be the instructions pretty much for all these. So for number 1, they're giving me x minus 3 times x plus 4. All of that has to be less than 0. Now I'm happy on this one. They've already factored it. So when it's already factored, you take both of these factors and set them equal to 0. And then solve both of these. So the first one, I'm going to add 3, and I get x equals 3. The second one, I'm going to what? Minus 4, and I get x equals a negative 4. So then it said, hey, make you a number line. So here's my number line. So the first point on the left would be what? A negative 4. So somewhere over here is a negative 4. And then somewhere over here is a positive 3. So I'm now going to test 0. Now notice, 0 is in between negative 4 and 3. So when I put a 0 in here, if it's true, I'm going to shade between that negative 4 and that 3. If 0 makes this false, then I'm going to shade the outsides and be done with it, okay? So to test 0, put a 0 in. So I got 0 minus 3. 0 plus 4 has to be less than 0. So y'all, this gives me a negative 3 times 4 has to be less than 0. So negative 12 less than 0 is true. Since it's true, shade where 0 at. Or how about 0 located? So since it's true, I'm going to shade where my 0 was located. So going back up here, I would take my number line and shade in between that negative 4 and that positive 3, which means that's the only solution I get. So the interval notation now notice, there's not an equals under this. So that means I'm going to use curvy parentheses. And the interval notation goes from that negative 4, and it's shaded all the way up to that 3, and curvy parentheses. Final answer. So since I only had this one part shaded, I had one interval. Now, over here, if you wanted to put numbers like 4 in it and 5 in it, well, 4 minus 3 is 1. 4 plus 4 is 8. And 8 times 1 is not less than 0. That's why anything after that 3 cannot be shaded, okay? All right, question number 2. So that one, they were sort of nice and already factored it. Which all the rest of these, we got to factor, okay? So here we go. X squared minus 13x plus 22 has to be greater than 0. So we got to factor this. So let me go right into factoring. And since everything's on one side already, with my 0, I'm happy. Now, had that not been a 0, I'd have had to move everything over, okay? So here we go. We got an x and an x. Remember, this is positive. Anytime the last number is positive, both of these factors have the same sign as the middle number. So they'll both be negative. And then you want to find factors of 22 that add to get 13. So 1 and 22 add to get 23. 2 and 11 add to get 13. So I'm going to put 2 and 11. Now, solve those. So once I solve these, I'll be able to set up my number line and go, okay? So both these were negative, which means you got to add to solve both equations. And then there's my positive 11. All right, so my number line is going to have a 2 and 11 on it, okay? So we're going to go number line. And I know 2 is before 11, so I'll have 2 and I'll have 11. So here's the thing. If you want your number to be in the middle, then you're going to have to pick a number like 3 all the way up to 10 probably. I'm going to test 0. I know 0 is in the first section, right? 0 is before 2, so I'm going to test this area. Check this out. If I test this area and it's true, I'll shade this area, skip this area, and then I'll shade the last area. So it's either outsides, shade, or the insides. Now, if this is false and it's not true, then the only place I'll shade is in the middle on it, okay? So let's test 0. 0's in the first section, so we're looking to see if this is true or false. So I got 0 squared minus 13 times 0 plus 22 has to be greater than 0. We all look at that. 0 squared is 0. 13 times 0 is 0. So the question of the day is 22 greater than 0, true or false? That is true. So I would come up here and shade where the 0 was located. Now, since I shaded the first section, I automatically got to shade the last section. Okay? Now, there's not an equals under here, so I'm still going to be using curvy parentheses on my interval notation. So here comes the interval notation. Now, since this one is shaded over here, that means this interval is coming in from negative infinity. And you've got shading until you hit positive 2. So then at 2, now we're going to use the union because that means and, but we can't start from the 2 because you can't start from the 2 and go because that's not shaded. You got to skip this whole section that didn't get shaded, and you got to start back up when you hit that 11. So then it'll go from that 11 all the way towards positive infinity. So if you got one interval, you get one interval on the answer. 2 intervals, you get 2 intervals on the answer, but one will start at negative infinity and the other one will end at positive infinity, okay? All right, so let me let y'all write that and then we get to move on. And y'all, I will say this, the answer MathLabs are wanting, it's wanting these intervals right here, okay? MathLab's not going to make you do the graph, and they just want these final answers. All right, so moving on to number 3. I have x squared minus 4x minus 22 greater than or equal to x minus 8. Let me make sure these numbers are right, y'all, real quick. Okay, yeah, I think I got it. All righty, so when we start these, this side has to have a 0 there instead of an x minus 8. So what we're going to do, we're going to move both of these at the same time to get a 0 here. So I would subtract the x from both sides, and then I would add an 8 to both sides. So I'm taking care of both of these at one time. So always, whatever you need to move, you basically turning it into its opposite, okay? So let's see what we get. We get our x squared. Negative 4 and negative 1 give me negative 5x. Negative 22 plus 8 gives me a negative 14. And all of this has to be greater than or equal to 0. So by moving the right side, I now have a 0 over there. All right, I'm going to change pens, so that was getting a little light. So now I've got my inequality, my polynomial on one side is 0. So now I would try to factor that. And then I'm just going to set it all equal to 0, right? So x squared gives me an x and an x. That 14 is negative, so that means you got unlike signs. One's positive, one's negative. All right, factors to 14 that subtract to get 5 would be 7 and 2. Since 7 is the larger number, it's going to be negative like the middle number, and the 2 will be positive. And you can always add these numbers and make sure they give you negative 5, okay? All right, so now to finish this out, set all these equal to 0. So I'm going to subtract 2 from my first one, so that x equals a negative 2. Add 7 to the second one, and get x equals a positive 7. So set up your number line. So let's see who's first. Negative 2 would be first right here, and then a positive 7. So 0, I know this time is located in between the negative 2 and 7. So I'm going to test 0 right in the middle, okay? True, I'm going to shade that. False, I'm going to shade the outsides. Now, what's nice, you can use this equation if you want to test your 0, or you can use this equation to test 0. I'm going to use the easier equation. So I'm going to do 0 squared minus 5 times 0 minus 14 has to be greater than or equal to 0. Well, that gives me 0. 5 and 0 gives me 0. And then that's going to give me negative 14 greater than or equal to 0. Well, y'all, negative 14 is not greater than 0, so that is false. So I cannot shade where the 0 was located since that was false. And since 0 was in the middle, I got to shade the 2 outside edges. I got to shade outside, okay? So if this was true, I'd have shaded it, but it was false, so it didn't get shaded. So since I've got the outsides, now look here, I got equals on this one, so I'm going to use brackets around my numbers. Infinity, always parentheses. So from negative infinity, you go until you hit negative 2. But at negative 2, we use a bracket because we had equals. Then we're going to union brackets from the positive 7 until it hits positive infinity and then parentheses. Okay, y'all, so they're not bad. It's just you got to factor them, and then you got to try to put up that number line, okay? So this one has an x squared is greater than 64. So what I would do is treat this like an x squared equals 64 and get it solved. And then once you get it solved, figure out your number line. Because I can solve this one without doing factoring. Because if you got an x squared term in a number, remember, we can do the square root stuff. But remember, if I take the square root of a number, I need a plus or minus in front of it. So square root of x squared gives me x. And this is going to be a plus or minus. Square root of 64 is 8. So you get x equals a negative 8. X equals a positive 8. So you're going to come do your number line. Here's our negative 8. Here's a positive 8. And I know 0, once again, is right in the center of a negative and a positive, okay? So if we can test our 0 here, true, we shade. False, we shade the outsides. So the question, is 0 squared greater than 64? No, because that means 0 is less than 64, not greater. So since that's false, we cannot shade where the 0 was, and we got to shade to the outsides. So any number outside of -8 and 8, when you square it, will give you a bigger number than 64. But any number in between here, like 7, 6, 5, when you square those, you'll get answers smaller than 64. All right, there is no equals under that, so I'm going to use parentheses. So it goes from -infinity to -8 parentheses, then union from the +8 to a positive infinity. Okay, so let me let y'all, starting to get stormy here, so I think I can knock out a few more hopefully before storms get bad. All right, y'all. All right, how about this? 81 minus x squared is less than or equal to 0. So this one, I would solve like I did the last one because there's not an x in it. So move the number over, take square roots. So I'm going to move that 81 over. So I get a negative x squared less than or equal to a negative 81. Now I want that to be a positive x squared, so I'm going to divide everybody by -1 so that I get an x squared. Remember, when you divide by negative, you got to turn that around so it's now greater than or equal to 81 divided by negative. Negative makes that a positive 81. So don't forget, when you divide by negative, to reverse the direction of your inequality. Now, y'all, I'm just going to take square roots like we did a while ago. And remember, square root of a number, use a plus or minus so that you get x greater than or equal to a plus or minus 9. Okay, so square root of 81 is 9. So I know my number line, I've got what, a -9 and a positive 9. Once again, 0's right in the middle. And 0's always in the middle when it's square root stuff pretty much, because you get one positive and one negative of them, okay? So put a 0 in here. 81 minus 0 squared is going to be less than or equal to 0. Well, 81 minus 0 is 81. Is that less than or equal to 0? That is false. So I'm not going to shade where the 0 is, and I'm going to shade the outsides. Now, I could have used this one, x squared greater than 81. If I'd have put a 0 in, 0 is not greater than 81, so that still would have been false whether you use this equation or that one, okay? This one has equals, so I'm going to use brackets. So you start at -infinity until you hit -9 bracket, union, bracket, from a positive 9 to a positive infinity. All right, so let's see what this one has, y'all. It's got a 2x minus 1 minus x squared is less than equal to 0. So the first thing on this one, I would put it in order. So I would do negative x squared plus 2x minus the 1 less than or equal to 0. And I don't like my x squared terms being negative. So what I would do to every single buddy in here is divide by that negative 1. Because you want your x squared terms positive, okay? So that'll make that a positive x squared minus 2x plus 1. And since I divided by negative, I got to turn that around and then my 0. So if you divide by negative, everybody gets divided by that negative, and you got to reverse the inequality from a less than to a greater than. All right, so now I'm going to factor, because that's a trinomial. I'm going to factor this one. So I got an x and an x. That's positive, so both factors have the same sign as the middle, so they're both negative. And y'all, there's only one set of factors for 1, and that'd be 1 and 1. And 1 and 1 I had to get 2, so I need that in here. So notice what's happening. I got repeating factors, so I know x minus 1 has to be greater than or equal to 0. So I'm only going to have one answer. So to solve this, I add 1, and x has to be greater than or equal to 1. I don't need to make a timeline on that because I've only got one answer. So anytime you get one answer, it's going to start at negative infinity until you hit that 1. Now it's got equals, so it's going to be a bracket, and then union from that 1 to positive infinity. Okay, so remember, since this is a multiplicity 2, it don't cross over the y-axis, it comes down and touches it and goes back up. Remember, it was tangent to it, okay? Oh, but y'all ain't got to know that. We just got to know how to get that answer right there. So, 2 answers. You got to set up a number line and test that 0. 1 answer, you exclude that 1 number, and that's it. All right, y'all, I got one more. So this one says x squared plus 16 is less than 6x. All right, so what's going to happen on this one? I've got an x term, so I'm going to get the x's on this side and have it equal to 0. If it had just been a number, then I'd have done my square root stuff. So we got to subtract that 6x from both sides. So notice I get an x squared minus 6x plus 16 less than 0. All right, so now we want to factor. So I got an x squared, that's an x and an x. Last sign's positive, so they'll both have the same sign as the middle, so they're both negative. And then let's find me factors of 16 that add to 6. So let me think. 1 and 16 is 17. 2 and 8 add to get 10. What's next, y'all? 4 and 4 add to get 8. And y'all, that's the only ways to get 16, right? 1 and 16, 2 and 8, 4 and 4. So since none of these factors add up to get 6, this does not factor. Okay, so none of these factors would FOIL to give me what I needed. So this does not factor. So the answer would be the empty set, no solution. Okay, so those are the, what was that, about 7 I just did. So those will be like the 7 you got on that homework. So that finishes up test 3 material. So what we're going to do tomorrow, we'll come in, review for the test 3, and then sort of try to fix anybody up on any homework issues, okay? I'm starting to get pounded, so I'm going to probably be shaky on my internet, I bet. So let me stop my share. And then I'm gonna stop doing this video, so I'll have it later.